Hey IB environmental students, today we're going to do more stuff on IAs, especially the planning IA. Here's the expectations and tips. Let's get started, superstars. So for this type of internal assessment, we once again have a rubric. You don't need to copy it down because it's available on Blackboard. Just know that sometimes for a planning IA, we might just do this section only. This allows for a little bit of creativity because you don't actually have to do the experiment itself. There's other times in this year where we actually will do the planning of the experiment and then do the experiment. So double check with me and ask, are we doing the whole experiment? For instance, for the soil IA, we are not actually doing the experiment. For the water quality IA, we are doing the experiment, and it matters in how you're going to do your planning. There's 3 aspects, each are worth 2 points for a total of 6 points. So how does scoring work? Remember, IB rubrics have very high expectations. Because of that, on the planning rubric, which is at a 6, even if you got half the points, that's just a C. But that's not bad, okay? I have to be very strict in how I grade you. You guys can do this. You're going to learn. You're superstars. And just stick with me along the way and read the helpful tools, and I think you can be super successful. So before jumping into this IA, there's a couple things we need to do. We first need to do some background understanding of the concept of our IA or the topic of our IA. For instance, let's say it was soil. So what do we know about it? Let's list out everything we know about soil types and how it relates to other things in class. Then we would think about what are the things we can actually change within this topic. Can we manipulate the type of soil? Can we manipulate the pH of the soil? And so forth. Those are things that could be independent variables. The teacher, me, would help you think about which of these are more likely to make for good independent variables. Then what kind of data could I reasonably collect and collect enough of it? Depending on if I'm actually doing the experiment, if I'm running the lab, that might determine how and what types of DVs we're doing. And lastly, what am I going to be making sense of this? Why am I doing this research? So a research question would let us talk about what changes to this independent variable and the data I'm collecting. What would they tell me about the overall topic? Getting back to why do I care? What does this tell me about soil and agriculture? And not only that, I'm going to then start planning listing this out in a more formal way and actually put it into my internal assessment for the first aspect. So I'm going to now write the aim and research question, and it will now include specifically my IV and DV. It will also need to give me context for my experiment, what conditions are there, and that means what is the location, am I in Virginia, where in Virginia, what type of climate is it, or is there a lot of light, etc. What kind of species is there? I need to give the scientific name and the common name. Remember, there's specific ways and formats for scientific name, and here's a potential way I could write this out that is very nice. Notice that this potential way does not match up with how this person has it. You can do it in a question format. Just know that this question format sometimes does not lend itself for the same level of detail. Notice that I have no idea what they mean by soil percentages. I don't know what 2 types of soil they're comparing. I don't know through this question exactly what they are doing and measuring. I can't tell its productivity. And I also don't have a scientific name for corn. The other thing is this hypothesis is a little bit stronger than this question, but it's still not up to par, so let's learn more about the hypothesis. So a hypothesis, remember, is an educated answer to a research question. It needs to be able to be tested and evaluated by the specific data you're collecting. And then the other section that's right around here for the aspect 1 is a rationale and a background. This needs to discuss and summarize how this research will connect with class concepts, such as how does this connect with what we've learned about for soil and agriculture. And you'll use those concepts to support whatever hypothesis you say. If you say there will be more productivity in the silt soil, well, I hope you're going to back that up with what you know about silt from class and how you know that's going to relate to agriculture. Discuss why the world should care about your research. Is it because there's an environmental bent on it? Is there some economic growth that could possibly happen? Is it going to help society? Be specific. Back up with case studies that are going to have these lenses. Now we've talked about sustainable development and make those connections. So here's an example. Pause and read it in detail. This one's medium to strong. The background gives me background information about why they picked their hypothesis. Do know that I don't know what the scientific name of corn is here. I also have not given a strong rationale that connects back to a care for the environment, agriculture, social, or economics here, but I do have good class background information. The next section is planning the actual different variables, such as the IV, the DV, and the control group. For these sections, I need to make sure I have units of measurement. They need to be super detailed, so go back in your notes or ask the teacher for help. And if possible, including ranges. So notice in this example, they're not doing that at all. They've used a table to be organized, but I have no idea what is the units of productivity. I have no idea what types of soil they're planning on using. Only include ranges if it is going to help you. Sometimes students really struggle with ranges. I am very unclear by what they mean here. I also don't know exactly how they're going to turn percentage of these things into actual methods. Usually students for soil like to turn it into a mass or a weight or a volume to get a variance on different types of soils. Again, I don't have the accurate amount of productivity here, and the range is not helping me very much with knowing how accurate or precise I'm going to be able to get this experiment. The next section is the control group, which is our baseline or comparison to the most normal group. For your soil IA, this could be thinking about what is the most normal or natural for your type of plant you're researching. This is important to control as you're varying things and making sense of how it could impact the environment, society. This is only a medium example. I think you could do a better one. The next section is planning the levels of IV. IB expects us to have 5 levels or variation. Look at this. They are varying the amount of silt soil versus sand soil. Do remember that it's fine to do percentages, but do know that that's not going to be something that's easy to execute in your methods and step-by-step description of how you're going to do the experiment. Something like grams or a volume is going to actually describe how you're going to actually get the soil and put it together to make different combinations or variations. This is important because we need to make sure we're clear and specific and we relate back to our research question and hypothesis. We're finally moving out of aspect 1 into aspect 2, and now we're talking about controlling the variables in an experiment. You guys might remember this as constants from another class. IB likes to call them controlling variables. This is a very strong organizational table for talking about this. Most students struggle to be clear and specific in this section. Notice that we want to not just say something general like keep the room conditions the same. That will get you 0 points. We want to be specific about what kind of conditions, what are the units we're referring to, because we would need to maybe monitor these or keep them the same. What are the possible effects that could happen and how I will control them, a method for keeping them the same. This one is only a 1 out of 2 points for this aspect. They have done a really good job of being very detailed in how they're going to control things, but I'm still missing some rationale on exactly how these things could affect their dependent variable productivity. If you can't control something or keep it constant, make sure you do list it out and describe how you would try to minimize it and monitor it. The expectation is you would have at least 5 rows on a table like this and 5 different constants in detail. The next section is the materials list. A lot of students struggle to have this be detailed and specific. This is the third aspect. Notice that these students don't have units on these types of soil. We do have a little bit of information here. I do not have a scientific name here. And so because we need this level of detail, we can summarize this as we need to include all amounts and types of materials and equipment. For instance, for the soil IA, it's not clear that we have the need for an oven. We don't know what kind of scale, how precise the scale is. We don't know how much volume we have of everything. We need to be very, very detailed and specific. So neither of these got full points, and some of them, like this one, might have even gotten 0 points because it's so lacking. So read this over and really stick with it. Better is much more detailed, much more specific, as much things you can talk about as possible. Think of this as an ingredients list for a recipe. If I don't know the exact amount of things, types of things, and how big my equipment is, I'm not going to get the right thing that I need to cook whatever I'm doing. And think about this like a recipe. The next section is also going to be like part of a ingredients list or recipe instructions. But if you had a big recipe, would you want to read it and it's a disgusting big block of text? No. So we're going to do this as step-by-step instructions. These can be numbered or bulleted. You also need to, in these instructions, include how to calibrate or prepare equipment. Like your materials list, you should include the exact sizes, level of precision, and units of the equipment, but you already have that information. You just include it in whatever step you're using the equipment. If it's probeware, you need to talk about how you got the probeware set up. If it's amount of types of soils and there's different percentages, you have to describe how you set up the soil that is 10% silt, 90% sand. I need to know exactly how you get that combination. I need it to be in detail. And related to that, be careful. You are going to be setting up 5 levels of IV, and each of them, for IB's reason of getting enough data, you need 5 trials for each of them at least. So you need to talk about setting them up. I need to see that there's that many trials, that many levels of IV. More is better, more detail is better here for sure. And with that, as you are talking about it being set up and how you're collecting the data, how you're measuring the data, eventually you need to talk about, once you have all that data, what will you do with it? Will you just sit there with raw data? No. We know from doing a TCP, we eventually have to process the data. We're averaging it. Maybe we're calculating standard deviation. Maybe we're going to graph it and get error bars. What kind of graph are we going to do? You need to talk about your future plan. This is going to sound like a data overview section from the DCP. And it is very important. IB wants to know what your plan is. And then there's this last piece that's totally optional, and you should not even start one unless you're done with everything else, even if it seems cool. So the first thing we're going to do is, for this section, if you want to do visual, I'm going to be checking, is everything else done if I see you working on this in class. But this visual would show us the procedural steps in a nice way. Students like doing this, it's fun, but it takes so much time, and usually students don't do it that well. So here's an example of a not strong method or procedure section. Notice immediately it's a disgusting block of text. It makes me overwhelmed. But they're also bolding things and I can't quite understand it. I don't have scientific names. I don't have a step-by-step chronological order of things. It's just very much not strong. I don't have volumes of the fertilizer. I also don't have the right number of plants. I immediately see I have 10 plants, but if I'm having 5 levels of IV and I need 5 trials, shouldn't that be 5 times 5, which is 25? So 25 is a magic number that sometimes I'll be looking for or counting up, that at least you have that many of whatever you're measuring. Here's a better example. Pause and you can read it over. Notice that this is very detailed. It has volumes, it has types of materials. It tells me how I'm setting up the different levels of IV. It tells me how I have multiple sets of that level of IV, how they're doing it. And this is not their whole thing. There's many more steps talking about how they end up processing their data. This is a very strong example, and I very highly recommend you look at it over. Here's an example of one of these protocol visual optional diagrams. This one got 0 helpful points. It actually kind of took away from their experiment because I didn't really understand what they were gaining from it. I also didn't know how they were really going to be able to grow corn in such a little pot of plants. I think this is not very helpful. If they really wanted to do this, it would have been nice to have information about how this trial is different than this a level of IV, but having this multiple times without telling me how they're all different is not helpful at all. Here's another way a student has done stuff. They've literally taken their steps and kind of synthesized them into the most simple version to kind of show me a flow chart of where they were going in their experiment step by step. But really think about this. This is just rehashing what you've done in detail. It is only necessarily if you think it's helpful to help you visualize it. It does not add and give you points. So don't do it as the first thing. So the big idea for planning is to be detail oriented and to really tell me what you're doing step by step and have a good way of collecting data on your hypothesis. You can do this, see more help on Blackboard, and ask me for help in class. Planning sections are totally doable. They just take some time. Wonderful job, guys. See you later.